about what it can do today, but also the capabilities that it's already developed and what that implies for the ability for neural networks to be visually intelligent. And even with the current level of scale that Sora is trained with, although it has a long way to go, we think there are some cool capabilities to highlight. And all of these capabilities have really emerged just from scaling compute and data. We don't have any explicit 3D or object level inductive biases in the model, and it's interesting that they can pick some of these up. So to start with, there's 3D consistency, of course, which has maybe been clear from a lot of samples. Here's another shot, also Japan. So as the camera flies through the scene, again, you see the geometry remains consistent. It has some notion of ray consistency actually built into the model. Here's another shot of Yosemite. Again, we see the same kind of trends. Even when there's people moving in the scene, the model is still able to reason about them in a way that's consistent with 3D geometry. They go a little extreme hiking. So one result, Ben Mildenhall, who's one of the original NERF authors, took one of these samples that we posted. So this is of Santorini in the Blue Hour, and he nerfed it, and it works. So that's a good eval in of itself, that the model has learned solid 3D consistency. Another capability we're really excited about is long-range coherence, and we think this is a big one for video generation systems, and is one of the most important capabilities that Sora has relative to what exists today. So the project's kind of fun. It's the balloon zoo shop in NYC is with a jewelry store and zoo, and you'll see that the model is able to stitch together, again, a cohesive narrative where it's moving between these different animals, it's all in the same shop, it all kind of has the same style and vibe to it. We can also persist characters. So here's an example of a robot living in a cyberpunk setting, and the character is the same across multiple shots as well. Yeah?
So going back to the 3D consistency, and maybe even the title of the talk as well.
Yeah.
If I think about using a video model as a simulator, I probably want to include a 3D like inductive bias. So is that something that you guys have thought about, or maybe how would you approach that?
Yeah, that's a good question. From our perspective, a lot of these phenomena are learnable at scale without much inductive bias. So, whenever you're in a compute-limited regime, it's always very tempting to want to bake in ideas like rate consistency directly into the model. And when you have small amounts of compute, that can be the optimal thing to do. One of the stories of deep learning, very broadly, not just for visual models, but also for language models, is that at some point these inductive biases come back to bite you. So if you have enough compute and enough data, usually, if you just have these big neural nets, and you just let them do their thing and learn without too much like human intervention, that tends to be a very successful recipe. So looking into the future, we don't think it'll be necessary, but it'll be an interesting thing to continue probing and investigating.
Ways that you can try to improve this, and in here we have, I guess, some examples, so it can be few shot to try getting like thread level detail and stuff. And we have a very similar process for videos that we use for Sora as well.
Did you ever compare just prompt engineering, just fine tuning it, with if you had the pair data?
The GPT model?
Yeah.
Yeah, that's a good question. We don't have any comparisons of that directly, but I think both are possible, and yeah, maybe depends a bit on, for example, to have DALL-E 3 in ChatGPT, there's a bunch of other things that ChatGPT needs to do, but it maybe depends a bit on the use case if you want to fine tune it or if you want to prompt it. Both are reasonable. Awesome, I'll pass it back. It gives all these details about where the camera is, about the lighting, about the textures, about as much information as we can get in here. And we find this greatly improves the results. So here on the y-axis is clip score, which measures how well the text prompt aligns with the image. And when you go from using the alt captions to the short synthetic captions, these really descriptive ones, you just get better and better alignment between the prompts and the captions. So this is really helpful, but then there's also an important problem that you need to make sure the captions you use when sampling are in the same distribution as the captions you've trained on. And so now this is inference, and so I gave, in this case it's DALL-E, an image of Berkeley campus, and then GPT under the hood turns that into a really highly detailed prompt. In this prompt, we've specifically prompted GPT in a way to make this a very similar level of detail to how it was trained. And then since the level of detail is really similar to how it was trained, it's very in distribution, and that gives the highest quality results.
Into details about the model though is, so some of these capabilities that we've shown are zero shot, for example, like the interpolation capability. Other kinds of capabilities we sometimes train the model to support. So when we're doing these kind of extension tasks, that's something that we sometimes support at training time rather than zero shotting. Yeah. And I'll hand it over to Tim to talk about recaptioning.
Awesome.
So this is all of these frames that you see in the middle video, essentially from scratch. We haven't actually gone into a lot of technical detail about how this works, but essentially almost all of the pixels you see here are kind of generated directly by Sora. The course extends to video as well, so we can specify any subset of frames to be grounded based on the user's input. And so in the example I'm about to play here, all of these videos will end in the same way. It's actually a video originally generated by Sora, but we can extend it backwards in time, so they start with different preludes. So this is like a hyperdimensional SF trolley or something. And so they all start differently, but they all kind of converge to the same result at the very end here. Another cool capability that we have is zero-shot video-to-video editing. So in this grid of videos, the one in the top left here is the input. This was actually also generated by Sora, but it could be a real video too. And using just off-the-shelf techniques from the image editing literature for diffusion models, in this case SVEdit, we're able to apply all kinds of stylistic transfers to that video. So for example, if we ask it to put the video in space with a rainbow road, you can do that. If you change it to a medieval theme, it'll do that, and it's very intelligent, right? Because it knows that cars didn't exist back in medieval times, so it replaces it with a red carriage. And you can change it to a pixel art style as well. I think one thing that's very cool about these kinds of results is the extent to which they're able to preserve some of the structural elements in the scene. So you'll see on the top left in the original video, towards the end here, it'll go through a cave. And you can see how that manifests in different styles. So in the bottom right, for example, you go through like a medieval castle instead of a cave. Another capability we're really excited about is interpolation. So the leftmost video and the rightmost video are the endpoints of this interpolation. And in the middle, we're using Sora to gradually transition from the left to the right. And you can do this, without needing to align these videos or, having to do any kind of like manual like key point specification. It's all just zero shot and learned by the model, which is really elegant. And it creates these very seamless transitions, which feel very cool. And one thing we like from the creativity perspective is it seems like this is a capability that is somewhat hard to do with other kinds of like, CGI-based editing. It really feels like a capability that AI is very good at, and it's kind of like a pure value add in that sense. Here's another example of this.
Tim.